All right. What we're going to look at is matrix multiplication and its application today. So, you know what a matrix is now from yesterday. And what we're going to do is, we're going to look at how we could identify the requirements of matrices in order to carry out matrix multiplication. From there, you need to be able to perform matrix multiplication. You have to be able to define pre and post multiplication, and finally solve problems involving matrices multiplication. All right? It's going to be a 45 minutes lesson, I think. Let's see how it goes. Now, so for matrix multiplication, it's a row by column method. Remember, row and column. So given that the matrices A is m times p and B is p times n, so the dimension of A is m row and p column, dimension of B is p row and column, then the matrix product C. So product of AB, where C is a matrix with a dimension of m times n. It has an element of this. All right? I will show you what to do step by step. It may be a little bit complicated. Looking at this, it's just basically A element in A, first row, first column, times B, first row, first column, and first row. Sorry, first row and first column. All right? First row, first column, first column, first row. Or first row, second column, whatever row it is. So for I is 1 to m and j is 1 to n. Looks complicated, but it's actually quite straightforward when I show you step by step. All right? This is just a warm-up, just for you to know that this is the notation we could use. So the next bit, this is important. You can only multiply matrices if they satisfy the row by column condition. All right? That is A must have P columns and B must have P rows. All right, look, go back at this. A has P column, B has P row. All right? It cannot be P times N and N times P. It has to be, if it is AB, P column and P rows. Otherwise, AB cannot be determined. That is the product of AB for two matrices, A and B, can be determined if and only if. Remember, if and only if the number of columns in A is the same as the number of rows in B. Alright? So, if the product AB can be determined, then matrices A and matrices B are said to be conformable. Or, in short, if matrix A times N is a matrix M times N matrix, and B is a M times P matrix, then the matrix product AB will be N times P. So look at that. If I've got N times N, I should have used P, and M times P and P times N, but it doesn't matter. So it will cancel off. The number of rows, the number of columns, and the number of rows will cancel off. And you will end up with the number of rows of A and numbers of columns for B. All right? I'll show you step by step what to do. Now, let's have a look at this. In front of you, in your handout, you can see clearly we've got a matrix A of this, which is, what is the dimension? 2 by 3, correct? And B is 3 by 2, 3 rows by 2 columns. So you need to know the rows and column quite well. Definitely knows the row and column quite well. Since the number of columns in A is the same as the number of rows in B, we can multiply A by B. The product AB should be a 2 by 2 matrix. So the 3 will be cancelled off. Now, can we do BA as well? B times A. Of course we can, because B is a 3 times 2, A is a 2 times 3. Right? The number of columns in B is the same as the number of rows in A. And therefore, we can multiply B by A. The product BA should then be a 3 by 3 matrix. So these are all the theory. Now, I'm not going to go through that because I've stated it just now. Let's go and look at the practical situation now. Let's do some examples. Now here, what you're going to do is, if I multiply A by B, I know this is a 2 by 3, correct? 2 rows, 3 columns. And this is a 3 by 2. So we know we are going to end up with a matrix of 2 by 2. Right? So go back. Think about what I said just now. I'm going to use this to multiply by this. 2 times 1. Alright? Rows times column. And then next. Row times column. Sum. Remember what I did? A sigma, which is a sum. Alright? So 1 times 3. And then sum of the next one. 3 times minus 10. 3 times minus 10. Yeah? So that will be your first element of the matrix AB. Now, what I'm going to do is you can do that first or that first. It really doesn't matter. It's up to you. But what I'm going to do is do this bit first. I want to show you something. So this time, I'm going to use some different color. Just watch what I'm doing, please. So here, this element here will be 1 times 1. 1 times 1. Alright? Then, I'm going to look at that element, 4 times 3 plus 4 times 3. Alright? And then finally, 5 times minus 10 plus 5 times minus 10. Right? You can see that what I've done is the row multiplied by the column, each column. Correct? Avoid using calculator at this stage. I'll show you how to use your calculator later. What I want you to do is think about you are multiplying row by columns. Now, if you watch please, if you come through here, you know that all this, the column, this belongs to B. This belongs to B. Right? All this belongs to B. Got it? Yeah? Whereas these are element of A. Yeah? So it's row times column, row times column. Now, can you work this two out, please? I am not going to show you, but I would like you to work it out. What are they? Write it down step by step. So the hint is this times that, row by column. Right? Row by column. So it's 2 times minus 4 plus 1 times 8 plus 3 times 9. So when you multiply two matrices together, you need to look at the dimension or the order. Alright, I'm going to clear the board and review my answer. I've got my answer already typed out. So, look at this. This is how I did it. 2 times 1 plus 1 times 3 plus 3 times 10. 2 times minus 4, 1 times 8, 3 times 9. And you've got a matrix of minus 25, minus 37, 27, and 73. Alright. say here, what do? I now know here 3 rows by 2 columns. I have got 2 rows by 3 columns. Therefore, I will end up with a matrix of 3 by 3. Correct? We'll end up with a matrix of 3 by 3. Can you think about how you're going to do this? So I have got now 3 elements, 3 by 3. 3 rows and 9 elements, 3 rows and 3 columns. So the first bit here will be this and this. 1 times 2 plus minus 4 times 1. All right? So keep going with the next few. So see the difference when you've got A times B and B times A. I'm going to get all of you to do it manually before I show you how to use your class pad. Swap that over to my iPad because it's easier for me to use my iPad. All right. So now, if you look at this, you should come up with a 3 by 3 matrix, and this bit here, it will be 3 times 2 plus 8 times 1, correct? Yeah? So you have to keep going until you end up with a 3 by 3 matrix. So let me review my matrix. I've written this up for you. You can go and have a look at it and check your answer. All right, one question for you. Is AB the same as BA? No. So, what we can say that, before I do that, since AB is not the same as BA, matrix multiplication is not commutative. All right? It's not commutative. Now, just quickly, you need to understand the word post and pre-multiply. We're going to look at if we use AB. A is post multiplied by B. Or you can say that B is pre-multiplied by A. Same with here. A is pre-multiplied by B, or B is post multiplied by A. Alright? So this is the description you need to know. What is post multiplied, what is pre-multiplied. In my years of working on matrices, I very seldom use the word pre and post multiply, but you do need to know. I generally just write out the matrices A times B or B times A. Are you all happy with it? If you are, I would like you to try example 1, please. I am going to give you approximately 3 minutes to do. So I'm going to suggest that if you've got 4 people in a table, do 2 each, and then compare the answer. If you've got 3, maybe 2, some of you do 3, some of you do 2. Just 2 minutes. Now, there are a few that you will not be able to determine the product. All right, there are a few that you will not be able to determine the product. And you have to give me the reason why. Yeah, so you have to give me the reason why.
So, if you get like something that you can multiply one way,
Yeah.
like, but is there like a possibility that if you like for CA, not that it works for CA, that if you did like AC and it worked for CA, is there a chance that it could not work for AC?
Yes, absolutely, because it's not commutative. Absolutely right. Now, Sam just asked me a question. If you could work a matrix multiplication of A times C, C times A may not necessarily work. Alright, for example, if A has a dimension of 2 times 4, alright, B has a dimension of 4 times 6. I could do AB because number of columns of A is the same as number of rows of B. So AB will then be have a dimension of 2 by 6. Whereas BA cannot work because B is 4 by 6 and A is 2 by 4. So you cannot multiply that. So you have to be very careful with your dimension. So AB and BA in that situation does not work. Alright, one more minute. Then I'm going to review my answer. Alright, have a look at my answers. So, which one cannot be determined? There are a few. AB cannot be determined because A is 2 by 3 and B is 2 by 2. 2 by 3 times 2 by 2, it doesn't work. But BA could work because it's 2 by 2 times 2 by 2 times 2 by 3. So it could work. And you know that 2 by 2 times 2 by 3, you will end up with 2 by 3, correct? So this is a sanity check for you. Sanity check for you, make sure that you know when you've got a 2 by 2 times a 2 by 3, you will end up with a 2 by 3. So always do your check. Say, again, let me illustrate. If A is 2 by 3 and B is 2 by 2, all right? AB cannot happen because the number of columns in A is different from the number of rows in B. But BA can be done because number of columns of B is the same as number of rows of A. So therefore the end result will be, the dimension will be 2 by 3. Alright? So let's keep going. AC, yes, it's possible. CA, not possible. B squared. Now, B squared, hey, listen. You can only square a matrix if it is a square matrix. Right? Only a square matrix can be squared, can be cubed, can go to the power of 4 or 5 or 6. Alright? That is the power of a square matrix. So only square matrix can have power. Now just remember one thing. This is the common mistake. Alright? B squared, which is 2, 3, 1 minus 1 times 2, 3, 1 minus 1 is not It's not 2 square, 1 square, 3 square, and minus 1 square. Alright? That is not correct. This is absolutely not correct. You cannot bring your square in there. You have to use your matrix multiplication. Got it? Make sure that you understand that you must have your matrix multiplication when you do your square or when you do your cube. Right? So therefore, what we'll have is that it's not 2 square, not 3 square, not 1 square, not minus 1 square. You have to do your matrix row to column multiplication. So DA cannot happen. DC, yes. C, in this case, you've got a row matrix times a column matrix. What it's giving you is the sum of this times that, 3 times 4, and minus 1 times 1. And we end up getting a 9. I will show you why we need this a little bit later. Alright? In terms of doing a proper application. So could happen, this is 2 by 1. This is 1 by 3 and 3 by 1. So you end up with 9. With 1 by 1, sorry, not 9. End up with 1 by 1. And finally, CD, you end up with, this is a 3 by 1. This is a 1 by 3. You end up with 3 by 3. Alright? So it's important to know that you need to know how to multiply a row column, a row matrix and a column matrix, or a column matrix by a row matrix. And of course, remember, it holds that the first matrix, the column number must be the same as the row number of the second matrix. Alright, grab your calculator out, please. I'm going to show you a few things. Alright? So let's keep your AB in front of you, please. A, B, C, D, E in front of you, please. So what we're going to do is try to do, let's say, a square matrix. Not a square matrix first. Let's try something like a BA first. So if I go to my class pack. Alright? Now go to main. Remember, when you're using your class pack, make sure that you clear all variables. Alright? Clear all and clear all variables. That's important. So that your class pack doesn't have any memory. Now, let's go to keyboard, Math 2. Alright, this tree here. Watch please. This column, row, and this will give you just an additional element. So if you tap on, if you want a 2 by 2 matrix, I can just tap on that one, that'll give me 2 by 2. Alright? I'll just tap on this one, that'll give me 2 by 2 straight away. So if I want to put B in, just go to each little box there, just type in 2, this is B. Alright? 1 and 3 minus 1. Oops. Minus 1. And click execute. That's done. So you store it there. Now if you want A, let's tap in. I don't mind starting off with the square matrix, and then I add in an extra column, which is the first bit here, an extra column. Alright? So now that I've got 2 rows and 3 columns, I can put in A. 1, 2, 3, and then 1, 4, 0. Okay, let's try something. Let's try AB. So you know that is A, drag it down, times B. Alright, you don't even have to have a multiplication sign. It's a invalid dimension. See? So your class pack is clever enough to tell you there's invalid dimension. But now, if I drag this across, alright, I drag this to this side and get rid of this matrix, and I tap execute, it gives you the answer. See, it is pretty clever. Now let's try squaring the matrix. Squaring B. You can use this. Let's drag it down. And do this. It will give you the answer. Or, watch please, if I just do this and go to the power of 2, it gives you the answer as well. It's so powerful. I mean, you can think about go to the power of even 3. Alright? Or 4. Or let's say I go to 20. It will work out the number, the matrix for you as well. So it's pretty good in terms of using your class pad. You need to know how to use a class pad. But for your exercises that I've given you, I would like you to do some without your class pad. Especially in Sadler exercise 10B that I've given you. At least question 1 to 18, please do not use your class pad, alright? You can use your class pad to check. Alright, so you've seen that, you know how to use your class pad. Oh, the other thing is, I'm going to show you how to multiply C and D. So C, I want a column matrix, but doesn't matter, I'm just going to add in 1, I'm going to type D in first. Minus 2, oops, what am I doing? Not right, it's minus 1, that is minus 2, and 3. Alright, doesn't matter, I'm going to put in my, I will do D and D times C first. This is 1, 4, and 1. If you click execute, it gives you that number. So if you want to do it the other way, just drag it down and you got it. You got a 3x3 matrix. So pretty much this is how you use your class pad. Pretty straightforward in many ways. Now, like I said, I would like you to do it manually first before we go on to do use your class pad. Now, next, application of matrix multiplication. So I've got 4 problems that I'm going to show you. Here, let's look at this matrix here. It's from a table. So it's sure results of high school at an inter-school sports carnival. School A has 1 first place, 2 first place, and 1 second place, and 1 third place. School E, you've got 2 first place, no second place, and 3 third place. What we want to do is we want to allocate points for each award in order to decide the school won the most points overall. So awarding 3 points for first place, 2 points for second place, and 1 point for third place. Shown in that diagram. What would be the total? You can use matrix multiplication to do this. Let me show you. So what I've done is I know that I want the total points. Alright, watch. What is the order of this? How many rows? 5. And how many columns? 3. What about this? 3 rows and 1 column. Now, obviously, you cannot use this to pre-multiply by that, right? But you can use this and then post-multiply by that, the points, and you can write it out that way. Alright, so writing this out in terms of matrix format is that you can input it in your class pad or you can do it manually. What happened is we will come up with a 5 by 1 matrix. What is it telling me? What is this telling me? Yep.
School M 6 points, B 11, C 9.
Thank you. That's right. So this will be the total points. So if I want to label this matrix, that will be the total point. Alright? And 6 will be school A, B, C, D, and E. So you can see that if you use matrix multiplication, B is a school who has 1 with the highest point. Alright? The thing is, with this sort of thing, exercises, sometimes it's more straightforward using a matrix. Especially if you've got lots of numbers and columns and rows. If you've got a calculator, you can just plug it in. And this is used quite a lot in terms of programming. All right, let's have a look at example 2. A manufacturer makes 3 products, A, B, C, and each require a certain number of units of commodities, P, Q, R, S, T. Matrix X below shows the number of units of each commodity required to make 1 of each product. So for example, product A, you need 1 P, 1 Q, 2 S's, and 3 T's to produce product A. So each unit of P, Q, R, S, T, and T cost the manufacturer $200, $150, $400, and $300 respectively. So write this information of matrix Y, which should be either a column matrix or row matrix, whichever can form a product with X. Form the product referred to in A and explain what information it displays. Now, if you look at this, what is the order? The order of X is 3 rows and 3 by 5. Correct? Yeah? Agree? Now, when you analyze a question like this, you need to think about, in this situation, am I going to use a row matrix? Or am I going to use a column matrix? What do I want? What are the information I want?
Cost of each part.
Yep, cost of each part. So therefore, this, you need to have a 5 by 1 so that you've got a 3 by 1 matrix where each row belongs to, it will be the cost of product A, product B, and product C. Got it? Yeah? Happy with it?
Happy.
Good. So, what would Y be then? Alright? What would Y be? What would the matrix Y be? Would be that. Now, what I've done is I label the top as cost. And this is PQRST, so that we know what this cost belongs to. Now you can put in the cost as a dollar sign here, or it really doesn't matter because we want it to be in the end product. So we know that we've got a matrix, and then you can use your calculator, or if you like to do it manually, to multiply X by Y. Alright? Post multiply X by Y, and then you know that this is the cost of producing unit A, unit B, and unit C, using all the numbers. Alright, now I'm going to give you about 2 minutes to attempt example 3, and then I'll explain it. I do want to finish this lesson today. So now you've got to think about fish and chip shops offering packages. And how are you going to write the information in the 3 by 3 matrix. Now, here, all right, it says here 3 by 3 matrix. So you do know that there's 9 elements in there. Correct? Yeah? So what would each row represent? And what does each column represent? The rows could be the 3 packages. All right, the rows could be the 3 packages. And that would be the content of the packages. Right? So you would have 3 rows. I'll start off with couples, family, and mega. Right? Then the top bit will be fish, chips, and potato scallops. Right? So what you do is couples, 2 pieces of fish. 200 grams. Now, I'm going to use 0.2 rather than 200 because I want all this to be the same units. Right? Instead of, if I use 200 grams, this will be 1500, which makes it a bit more complicated in a way. So I'll rather use 0.2 and then 6 pieces of potato scallops. So let's check them this. Now I know that there's a tendency for you to skip and wanting to do use your matrix applications using your class pack, but just bear in mind that you must know the basic first, not using class pack, because you may get count free. Matrix and count free section where you need to use to calculate matrix multiplication manually. All right. Now, so this is how I label it: couples, family, and mega, fish, chips, and potato. You can have F, C, and P. It doesn't matter. C, F, and mega. The only thing, listen. The only thing is C is couple, C is chips. So therefore, you might be confused. All right. I will actually write it out properly. At least for the first matrix. And then part 2. The shop has ordered for 20 couples, 50 families, and 16 mega families. Calculate using matrix method the number of pieces of fish, the number of kilos of chips, and the number of potato scallops needed to do the ordering. So now, what you need to think about is you want the total number of fish, the number of kilos of chips, and the number of potato scallops. So, you know that this is a 3 by 3. You want, when you multiply, you want results where you can work out the total number of fish, chips, and potato. Correct? You know that this is 3 by 3. Right? You want the end result is fish, chips, and potato, the total number. So you know that the order, you've given the order of whatever. Let me read the question again. So if you're given the order of 2 pieces, hang on, 20 couples and 50 families and 16 mega family. All right. What do you want? Are you going to have this in a column matrix or row matrix? Row matrix. Why? 1 by 3 times 3 by 3 will give me 1 by 3, which means each the total number of pieces of fish can be determined, the total weight of chips can be determined, and the total number of potato scallops can be determined. Yeah?
You can also post multiply, but with a column matrix.
You can, if you want. 3 by 1 or 1 by 3. Either way. Thank you. Yep, you can post multiply it with a column matrix, that's fine. Or multiply it by whatever. It doesn't matter. Either way, as long as you can determine the number of chips. Actually, if you think about it, you can't, if you multiply by, post multiply by it, you won't actually get that. Would you?
It'll just be the other way around. So
2 by 6 by. No! No. If you do it by, hang on. Alright, 20, 50, and 16. What would happen? You will get 20 by 2 plus 0.2 times 50 plus 4 times 16. What do you get? It's not logical, is it? So you actually have to use this to multiply by that to get the number, total number. So you cannot post multiply by, yes, you can post multiply by the column matrix, but you don't get the right thing. Alright? We're going to take up a couple minutes of your time. So you need 500 pieces of fish, 60 kilograms of chips, and 720 potato scallops. So you need to really think about what you want. You want it to be in fish, chips, and potato scallops. So you have to multiply by the pre-multiply it by your row matrix. Alright, so and therefore, then you can work out the cost, which is this, the number of fish times the cost, the number of potato times the cost, the number of scallops times the cost. Alright? Okay, give me another 2 minutes, please. Let's have a quick look at example 4. The ticket sales for a show are shown in the matrix T below for 3 nights of the shows. Adult ticket cost $18 each and child tickets were $5 each. Now, represent the ticket prices in a suitable matrix P and then use the matrix multiplication to calculate the matrix S, the product of P and T. So you know you need P and T. It did not tell you whether it's T times P or P times T. But you want the ticket price to calculate the product of P and T. So in this case, what I'm doing is writing up P, the cost of adult and child. $18 per adult and $5 per child. And then S is P times T, and you work out Thursday night, Friday night, and Saturday night, how much takings you get. Alright, you need to work out how much takings you get. From there, part B, explain what information matrix S shows. So S actually shows the total income for ticket sales for each of the 3 nights. Now, something like this, always explain. How much is the taking for Thursday night, how much is the taking for Friday night, and how much is the taking for Saturday night. And following that, you should be able to work out C by how much did the income from the Saturday night show exceed the Thursday night is one thing and with the other. You now need to show how to multiply matrix at S to obtain a matrix that shows the total income over 3 nights. So you need to use the information that's given to you. What happened is you can just sum it to show the income. Alright, watch. You can just sum it to show the income. But then the question asks you to show a matrix weight. So therefore, it's a 1 by 3 times 3 by 1. So you want one of these, one of these, one of these, add together. And it's 8996. Right? 3 by 1 times 1 by 3. Alright? Sorry. 1 by 3 times 3 by 1. Alright? Therefore you've got 1. 1 by 1. So therefore, you know that you have the sum. You can just simply add it up, but it's not what you want in the question. You need to show it with matrix. So the next one, what you need to do is start thinking about the cost of the child is now 0. We are changing the P. The cost is 0 and A is now 20.5. And again, this time see, I'm multiplying by 3 matrices. So this is a, watch please, this is 1 row by 2 columns. This is 2 rows by 3 columns. Right? And this is 3 rows by 1 column. So you can see that I can multiply this first, right? Because I will end up with 1 by 3, and then multiply that, I will end up with a 1 by 1. Or you could just work on this first, get a 1 by 3, and then sum it together, or multiply by a column matrix. It is up to you. So there are many ways of doing it. I'm showing you the matrix form. So write this down. 1 by 2, 2 by 3, and 3 by 1. Alright? So, one last 30 seconds. So therefore, the sales of 65 make up the shortfall. Alright, I'm going to stop here. Sorry, it take longer than expected because of the technology problem.